Hi everyone. Today we're going to talk about translations. So the last set of notes, we first started discussing different transformations. So the topic in the last set of notes was rotations, and today we talk about translations. A translation is a transformation that moves each point in a figure the same distance and in the same direction. Now, the figure's shape is still maintained, so it's still the same size, still the same shape. So a translation is an isometry, just like a rotation. The transformed figure is called the image. So once you do the transformation, this is kind of like the after, while the original figure, kind of like the before, is called the pre-image. So the pre-image is the before, the image is the after the transformation has happened. Now, for a translation, a vector can be used to translate the pre-image in the coordinate plane. A vector, which we're going to learn a little bit more about, gives you direction and magnitude. Magnitude is also known as length. But what it does not give you is a set location. So vectors can kind of float anywhere in space, but they do show you a direction and they do have a definite length. When you write a vector can be written like this. It almost looks like an ordered pair, but your kind of parentheses here are pointed. So you don't have just regular old parentheses. A represents the horizontal shift of X, and B represents the vertical shift of Y. So this is what a vector looks like. It kind of looks like an arrow. You have an initial point, and then where the vector kind of makes you land, this is called the terminal point. When you think of like terminal or terminate, that means to end. And so this is the terminal point. It's kind of like the end point of that vector. This is not a ray. So the arrow shows you the direction that the vector goes in and the length of it, but it is not a ray. So in general, a vector is written as A comma B. So the horizontal change A and the vertical change B. Specifically to this vector, if I figure out the horizontal change from E to F, then I'm just going to count over 1, 2, 3. So that was a horizontal change of 3. So my A would be 3. And then to my terminal point, my vertical change is 1, 2, down, so -2. So -2 would be my B value. So specifically for this diagram, this vector is 3, -2. So we're going to talk about vectors today. We're also going to talk about when you translate a point along a vector, sometimes you get this notation, and this is mapping or coordinate notation. So the way you read it is that the point x comma y maps to the point x plus a comma y plus b. A is still denoting the change horizontally, and B is still denoting the change vertically. But it shows you that you go from your original point in your pre-image to your image point by adding A and B. So some examples that we're going to talk about are going to require that you use words or mapping notation or the translation vector in order to describe the translation that happens. So in words, you would just write a complete sentence. For example, if I was translating the pre-image to the image, the figure is translated left 5 units and up 3 units. So from a point in the pre-image, if I go left 1, 2, 3, 4, 5, and I go up 1, 2, 3, I end at my image point. Perhaps this is point A, so that would mean that the image point would be called A prime. And it kind of has like a little apostrophe up there. So we discussed that last time, but you are going to be writing it today. The coordinate or mapping notation tells you the same thing. Any point that is located in your pre-image, if you subtract 5 from the x value and and you add 3 to the y value, you're going to end up at your image. And then the translation vector would be showing you that you go left 5, up 3, and that's the direction that you're moving in. So when you translate a figure, the image is always going to be congruent to the pre-image. And remember, we talked about this in the last set of notes. That means that translations are isometries. The orientation of the pre-image and its image are the same, so it's not kind of flipped or rotated at all. And a translation can be described with words, notation, or a vector, as we saw here, and as we'll practice in our examples. So we're going to translate triangle ABC along a given vector. We need to label the pre-image first. We need to graph and label the image once we do the translation. And then we need to write the coordinates for the image and the mapping next to the graph. So we have a lot to do on these problems. They're simple, but they require a lot of different answers. So the first thing, label the pre-image. So I have points A, B, and C already written here and drawn on the graph, but I need to label them. So 1, -2, that's point A. 3, 1, that's point B. And 0, 4, that's point C. Now my translation vector is -5, 0. Remember that this shows the horizontal change, so we're going to go to the left 5. And this shows the vertical change, so we're not going to go up or down at all. We're staying where we are vertically. So from each point in the pre-image, I'm going to draw a translation vector, -5, 0. So if I go over 1, 2, 3, 4, 5, and up none, then I'm just going to go ahead and create a little arrow to show you the vector. And if this is point C, then this is point C prime. So this is my image, this is my pre-image, and this is my image point. Let's look at B. If I use my translation vector, -5, 0, I'm going to go over 1, 2, 3, 4, 5, and up or down none. So my pre-image is point B. My image is point B prime. And then finally, for point A, that pre-image is here. If I go along the translation vector 1, 2, 3, 4, 5, and up or down none, then I end up at point A prime. So if you connect A prime, B prime, and C prime, you have your image. Which truthfully, if you struggle with drawing prisms, this is a good way to try and draw prisms. This is a rectangular prism that we have pictured here. So we labeled the pre-image, we graphed and labeled the image, we need to write the coordinates for the image, and we also need to write the mapping. So I need the coordinates of A prime, B prime, and C prime, and then I need the mapping. So I'm going to map every point x, y to its image point. So A prime is at -1, 2, 3, 4, -1, 2. B prime is at -1, 2, +1. And C prime is at -1, 2, 3, 4, 5, +1, 2, 3, 4. And every point we took the x or y value, and you add -5 to the x value, and you do nothing to the y value. Notice that the y values have remained the same. But the x values have had 5 subtracted from them. So we take the x value, we subtract 5. We take the y value, we add nothing. So this is the mapping. So now that you've seen all of those things, we labeled the pre-image, we graphed and labeled the image, we wrote the coordinates for the image, and we wrote the mapping. I want you to pause your video and try example 2. So check your work with mine. Notice how all of the translation vectors go in the same direction, and they're all parallel. That is not a coincidence. So you should be traveling 4 to the right and 2 down to get to your next point, your image points. And so those vectors are going to look like they're all parallel to each other. Check your image points, so A prime, B prime, C prime. And then if you're unsure how to get the mapping, you're always mapping x comma y to the point that has x and y transformed like this. So if this is a positive 4, your new x value will be x plus 4. And if in the translation vector you have minus 2, then this will be y minus 2. So let's go ahead and change to our second page of notes. It asks you to translate triangle ABC along the given mapping. Again, we need to label the pre-image. We need to graph and label the image. We need to write the translation vector this time, so it's not given to us, we have to write it. And we need to write the coordinates for the image next to the graph. So here, let's go ahead and label the pre-image. I have -3, -4, that's point A. I have -2, 1, that's point B. And then 2, -2, that's point C. So it tells us that we're going to map each x and y value to the point x minus 2, y plus 4. That means that we are moving -2 horizontally and up 4 vertically. So each each point, I'm going to move to the left 1, 2, and up 1, 2, 3, 4. That's point B prime. For A to A prime, I'm going to move to the left 1, 2, and up 1, 2, 3, 4. And then for the point C prime, I'm going to move to the left 1, 2, and up 1, 2, 3, 4. That's C prime. So here is my image. So we graphed and labeled the image. We wrote the translation vector that came from the mapping. And now we need to write the coordinates for the image. So A prime, B prime, C prime. A prime is at the point 1, 2, 3, 4, 5, so -5, 0. B prime is at the point -4, 1, 2, 3, 4, 5. And C prime is at the point 0, 2. Notice that if I took each x and y value and I subtracted 2 and added 4, I would get my image values. So if I took -3 minus 2 and -4 plus 4, -3 minus 2 is -5, and -4 plus 4 is 0, and that's my image value, or my image coordinate. So in the last few examples, a polygon and its image are shown. We need to describe each translation using words, coordinate notation, so mapping, and the translation vector, all 3 of them. So I'm going to do number 4 with you, and then you're going to do numbers 5 and 6 on your own and check. So first identify which one is the pre-image and which one is the image. So here's the pre-image. I'm going to start with this point. It looks like it goes to here, so traveling to the left, 1, 2, and traveling up, 1, 2, 3, 4, 5, 6, 7. So it might be easiest to start out with your translation vector. We moved left, -2, and we moved up, 7. My mapping would take the point x, y, and it would move to x minus 2 and y plus 7. And in words, we would write that we shift left 2 and up 7. So pause your video and try example 5. So the most important thing with problems like this, because I know a lot of you want to rush through them, is to identify which one is the pre-image. So here's the pre-image. If you start from a point, you travel to the right 7 and down 5. So here's our translation vector, 7, negative 5. Here's our mapping, xy moves to x plus 7 and y minus 5. And that translates to a shift right 7 and a shift down 5. Finally, let's try number 6. Pause your video and try it out. So look at my answers. It looks very much like I shift to the right 4 and down 5, but why would these not be correct? Why do I not shift right 4 and down 5? Why is this not my mapping or this my translation vector? I identified the pre-image as this one, and this is where I started. I started from B prime and I moved to B, but that is not the way that we should work. So your pre-image is the original triangle A, B, C, but your image is A prime, B prime, C prime. Remember that the primes, here, here, and here, that means that it's the image, the after. So I should not have gone from B prime to B. I should have gone from B to B prime. So I shift 1, 2, 3, 4 to the left, and 1, 2, 3, 4, 5 up. So instead of shifting right 4, I should have shifted left 4. And instead of going down 5, I should have gone up 5. My coordinate notation is okay, except for I should have done x minus 4 and y plus 5, which means that the minus 4 should be here in the translation vector, and a positive 5 should be here in the translation vector. So watch out for identifying your pre-image and your image.